Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Cubie A7S single board computer. This is a new octa-core ARM board from Radxa with some interesting connectivity. So let's go and take a closer look. Right, here we have our Cubie A7S, which is a model with 4GB of RAM, for which I paid £41.39 including taxes from AliExpress. There are also 6GB and 8GB models, with the prices currently ranging from $54.13 or £41.39 for 4GB to $68.61 or $52.39 for 6GB and $81.28 or $62.19 for 8GB. However, as with all hardware right now, prices are in flux, with A-Race currently listing this 4GB board for $39 or £30. But regardless, the Cubie A7S has a fairly traditional SBC price tag, so makers may be able to afford this board to use in projects. In theory, the board is available with up to 256GB of onboard eMMC flash storage, but right now I can't find any models for sale with eMMC. So let's open it up, and to do so we need to remove some shrink wrapping. Let's try and do that with Stanley the knife. So that's opened it up. It has. Oh, I can never get this stuff off, but let's do so. Yeah, so that was not bad. And we can now open the little box, get it out. Nice little board, very compact and USB-C. Crinkle, 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 and all that. And there we are, our new single board computer. And at first glance, some of you may look at this and think, oh, it's got a Raspberry Pi Model A form factor. But it doesn't. And just to prove it, over here I've got a Raspberry Pi 3A Plus. And if we put the Cubie A7S down next to it, we can see it is considerably smaller. Specifically, the Cubie is 51mm square compared to 65 by 56mm for a Pi 3A Plus. So the Cubie is a very compact new SBC, which in the current market is selling at a very decent price. At the heart of the Cubie A7S is an all-weather A733 system on a chip, which is actually located under the board. Here it is underneath, and this is an octa-core chip which contains 2 ARM Cortex A76 cores clocked at up to 2 GHz, as well as 6 ARM Cortex A55 cores clocked at up to 1.8 GHz. Just to be interesting, the A733 also contains an Alibaba RISC-V Zante E902 microcontroller core clocked at up to 200 MHz. And there's also an Imagination PowerVR BXM464 MC1 GPU and a 3-TOPS MPU. Also under the board, the chip next to the SoC is the RAM, here 4GB of DDR5, and we also find a microSD card slot and a 4-lane MIPI camera serial interface or CSI connector for hooking up a camera. Finally, there's a 3-pin fan connector, and this board will need at least some kind of passive cooling, although no cooling solution is supplied or even sold by Radxa. If we flip the board back over to keep it happy, there we go, we find all of the traditional connectivity grouped together on one edge. Here we are blessed with gigabit Ethernet, which is fantastic on such a compact SBC, as well as 3 USB ports. Specifically, on the far end, we have a USB Type-C connector that is mainly used to provide 5-volt power, with a 3A adapter being recommended. However, this port also offers USB 2.0 and OTG functionality. In the middle, we next find a second USB Type-C connector, which is specified by Radxa as USB 3.2, with no more information being supplied, so I suspect it's got a 5 gigabits per second interface. However, this port also offers DisplayPort Out mode, offering up to 4K video output at 60 frames a second. So we'll be hooking this port up to a monitor, as the Cubie A7S does not have an HDMI socket. Finally, the last port is Type A USB 2.0, which is handy for connecting a mouse and keyboard. Turning 180, on the opposite edge we find a wireless module that offers Wi-Fi 6 and Bluetooth 5.4, as well as an associated antenna connector. There's then an FPC PCIe connector, like those we find on a Raspberry Pi 5, and which has a single-lane PCIe 3.0 interface. This can be used to connect an adapter board with an M.2 slot for an NVMe SSD. And this can be bootable if appropriate firmware is uploaded to the Cubie's SPI flash. And lastly, there's what's described as a USB boot button. Finally, the top of the board is flanked by a 30-pin GPIO connector, as well as pads for adding a second 15-pin GPIO connector. And this is a little strange, as the Radxa and seller websites show the Cubie A7S with the second 15-pin GPIO connector fitted. But it seems the board I have here is not unusual, with shipped hardware only having the 30-pin GPIO header. Greetings! I've now got the board all connected up, as you can see, in a rather unusual configuration, because I've had quite a few problems getting this board to work, or at least to work with a functional keyboard and mouse. And whilst I'm sure some of you will say this board's designed to be used headlessly, I'm sure that is true, it does have video output from its USB-C port, it has got a desktop operating system image available, and I wanted to test that therefore in the video. And first of all, I set things up like this, with a Raspberry Pi keyboard and mouse combination plugged into the Type A USB 2 port, and however I powered things I couldn't get that to work, and so I've ended up with what we've got here, which is a powered USB hub plugged into the USB-C port that provides data and also DisplayPort Out mode for video, which is now coming out of here. We've got keyboard and mouse plugged in here, we've got a Raspberry Pi 4 power supply powering the powered hub, and we've got a power supply plugged into the Cubie itself. It requires at least 3 amps at 5 volts. Here I'm using a 30 watt Radxa power supply. I have, by the way, tried 6 different power supplies, including the Raspberry Pi 5 power supply, which can supply 5 amps at 5.1 volts. Even that didn't allow things to work in the previous configuration. Oh, and also under here I've got a heatsink on the SoC. We'll use the magic of filmmaking to take a look at that. There we go. And so hopefully things will now work. So let's turn on the power. And we've now got a green LED. We'll watch this in real time so you can see the full experience of booting a desktop operating system on the Cubie board from the microSD card we've got over here. It takes a little bit of time. I once threatened my students that I'd learn to play the harmonica for moments when we have to wait for things to happen, but I never learned to play the harmonica, and the LED has gone out. That's a good sign. It means things are about to happen on the screen, and they are, hopefully, and hopefully, yes, things are there, so we will flick across to the full screen video output, and here we are going through. It's about to log itself through to the desktop. Guess what we're running? You'll see in a second. And where are we? There we are. We can log in like that. Radxa is the stock password here. Radxa and Radxa on the account. And you'll see we're going to boot into, guess what? Yes, it's a KDE Plasma desktop on what is called Radxa OS, but it's basically a Debian operating system based on Debian running a KDE Plasma. And here we are. It has booted up, and it's working very nicely. I think it's fantastic you can run a desktop operating system on this tiny little SBC. It still excites me, that reality of the modern world. Anyway, having said that, I must point out one negative, which is if we go down here, we can see we don't have any audio. Remember, our HDMI output here is coming via USB-C port with DisplayPort out mode. And clearly here, this isn't giving us access to any audio. Let's just have a look in settings. There we are. And we'll show inactive devices. And clearly, we've just got dummy output here. That obviously isn't going to give us any audio output. So this might be a function of the software. It could be because I'm using a powered hub. Don't think so. But anyway, I don't have any audio at the moment on this system. Let's look what's pre-installed. This is exactly what you get straight out of the box, as it were, other than the fact I've applied a bit of scaling so we can see things easier in the video. And this is a pretty lean install. We have an image viewer for, guess what, viewing images. We have under Internet, Firefox, KDE Connect, as we can see. We have under Multimedia a video player. Under System, the sort of things we'd expect under System. And under Utilities, for Utilities. There we are. So let's go back to System and run up HTOP, because some of you like to see HTOP. There it is, running along. We can see we're using about 900 megabytes of our 4 gigabytes of memory. We've got our 8 CPU cores, not very busy at the moment, and this is what's running on this machine. I know some of you get very excited by looking at what's happening in HTOP. Can't give you too much of it. You get overexcited, so we'll close it down. There we are. And I'll just show you how responsive this system is by launching the Dolphin File Manager. Works pretty nicely. We've got a reasonably responsive system here. And of course you want to see a browser. Let's run up Firefox. It'll take a little bit of time. It's a little bit heavy, this operating system, for a board running from microSD card, but it's not bad. It's fully functional. And I've got it here displaying the downloads and resources page for the Cubie A7S. This is where I got the operating system images from. We just go down here. We've got the Radxa Cubie A7S releases page. Takes us across to GitHub. There are various images available, some pre-release, some not pre-release. Here is a pre-release Debian Trixie just with a command line interface. But what we're running here is this image, and there are some other images, as we can see down here. I've been experimenting with these two images based on Debian Bullseye, but I've not been able to get these to work with the video output, which is why we're using the Trixie image up here somewhere. Where is it? It was there. This is the image we're running here. So let's just close down that and that, because I have got YouTube here. I know we aren't going to be playing YouTube on this system, certainly not without any audio output, but we will just see what it would do. Let's bring up our standard test video. And this system is more responsive than many SBCs I've tested, particularly small SBCs. Let's just take it through to make sure we're in 1080p like that. We are, and bring up Stats for Nerds. And we'll go back to the start, I think, just to give us a bit more stuff to actually be playing. And it's not disastrous, is it? That's not the best sort of glowing sort of praise for it, is it? Not disastrous. We have got lots of drop frames, as we can see at the top, but it is watchable. It's not too bad. So anyway, we always have a look to see how YouTube can play. Can a system play a YouTube video? Can it stream a YouTube video? It gives us an idea about its power more generally. So anyway, there we are. We've got geese on the screen. That has to be good. And we've tested out a little bit of the performance of the Cubie A7S, which, as you probably gathered, is an SBC that's given me some issues. Right, I've now connected an NVMe SSD to the Cubie A7S using its PCIe connector and the type of adapter board we use to connect a NVMe SSD to a Raspberry Pi 5. And some of you might be thinking to yourselves, rather than this configuration, could you use a Bluetooth keyboard on the board? And so let's go across to the desktop, and if I just show you in settings, unfortunately, Bluetooth adapters are not found. I've been partially successful trying to get Bluetooth to work on this system and to use a Bluetooth keyboard and mouse combination. That hasn't worked. So anyway, let's ignore that for now and go back to what we were looking at, which is the NVMe SSD. So let's do an LSBLK. And there it is. I didn't have to do anything to get the drive to work. It was just recognized straight away on the system, which is rather nice. And guess what? We're going to test its speed. Let's bring up the appropriate HD parameters command. There we are. And we'll press enter and put my password in. Radxa, haven't changed it from the stock one, default one, And what we're going to get, very exciting, it's going to be 600.87 megabytes a second. And whilst we're here, we should also test the speed of the microSD card, because why wouldn't we? So let's change that to the microSD card, which is MMC BLK1, like that. It will of course be slower, considerably slower. How much slower? 84.21, that's not bad. That's pretty good for a microSD card on a single board computer. So there we are, we've got pretty decent test results for storage speeds on this low-cost SBC. Right, I thought we'd run a couple of my favourite SBC performance tests, the first of which is a Sysbench CPU test, which factors prime numbers here to a maximum value of 20,000, but with an events limit of 10,000. So in practice, this should run in just a few seconds. So let's execute the test. Here we go. Very exciting. What are we going to get? 2.84 seconds. And this compares to 2.43 seconds on a Raspberry Pi 5 and 3.59 seconds on a Raspberry Pi 4. So the Cubie A7S is sitting between those two Pi models. So let's run another test. Let's close that down and run up GIMP, the GNU image manipulation program, which I have installed, as you can see, installed with no issues here on the Cubie. Here it is. There we are, it has run up, and we'll go to File and New, do a standard 1920-1080 image like that, and then go to Filters and Render and Lava, and then bring up exactly the same setting on a Raspberry Pi 5 and set them both off at exactly the same point in time. Here we go. Let's see what we're going to get. And yes, as expected, the Raspberry Pi 5 has won, with a Cubie coming in second. But a 4GB Raspberry Pi 5 is significantly more expensive than a Cubie A7S, which, in terms of its hardware, is a very good value single board computer. So, here we are in the final segment of the video, which it seemed appropriate to record with the Cubie A7S running before me here on my desk where I've been testing it, rather than up against the green screen as I normally do, because this has been a rather unusual SBC review. In the past decade and a half, something like that, I've reviewed 80 previous single board computers. I'm pretty sure this is my 81st SBC review, and that's included 14 previous boards from Radxa. And I mention this because I've never had the issues I've had with this particular board in terms of having to use a powered hub to get keyboard and mouse working, as I've explained earlier. And the board is now working perfectly well in that configuration. If I press this button, we go across the desktop, we can see some system information I didn't show you earlier, all about the software that's running here in Radxa OS and Debian and the hardware, etc. Everything is absolutely fine. And I've also now done some power tests. I can tell you the board uses about 3 watts at idle and about 5.5 watts at load in a CPU suspense stress test. And do note that's the power use for the power adapter that's powering the board. That doesn't include the other power adapter that's powering the powered hub, which I've needed to use here. And just to run you through again what's gone on, I recorded about a month ago now the introduction to this video, shot the intro and the unboxing and the spec section of the video, and then, as I often do, if it's getting towards the end of the day, I thought I'll just put an SD card in, see if it's going to boot up and be okay for what I'm going to be doing tomorrow. Did that, it booted to the login screen, and I almost left it there. I thought, no, I'll just try logging in. Couldn't log in. Keyboard didn't work, mouse didn't work. So, oh well, I've just plugged something in wrong, did it all again, didn't work. Tried another keyboard, didn't work. Tried another keyboard, didn't work. Read up a bit, thought maybe this was a power issue with the board, hasn't got quite enough power to supply to the keyboard and mouse. Tried many of the power supplies that I told about earlier, didn't work. Tried a powered hub into the USB-A port to try and power the keyboard and mouse that way, also didn't work, and had to give up and move on to other video production because for channel demand constant content, you can't spend too much time on a particular thing. And eventually I've come back to it with a new USB-C powered hub, as we've been using in this video, and it's worked. But
I keep thinking, have I done something really stupid in terms of looking at this board? Which is why I've mentioned I've done a few reviews of these SBCs previously. I've battled boards that had issues to get running, and I never quite like this. And it can't be, I don't think, the board hasn't got enough power. It's on the edges of power supply, because we've tested it earlier in the video here with this, an adapter board with an NVMe SSD, which is a lot more power than you possibly need to supply to run a keyboard and a mouse. So I think it must be something to do maybe with this particular board. Maybe it's just a faulty board. It's not negotiating right with a keyboard and a mouse to supply the power they need. Is that a software issue? Is it a hardware issue? I just don't know. I almost didn't post this video, but I thought I will. I'll show you what's happened. I do like this board. As a headless board, it's brilliant. As a non-headless board, it's good. You just have to use, at least for me, the powered up to make the thing work with a keyboard and a mouse. So there we are. And I've had such fantastic success with previous Radxa boards. One of my favourite ever single board computers is the Radxa X4, this brilliant M100 system. I've had so many hundreds of hours of use out of this board. Brilliant SBC. I really like boards like the Rock 5 ITX from Radxa. So I don't quite know what's going on with this particular bit of hardware. Anyway, things are what they are, and I've now explained to you everything that's gone on. You've had the full warts and all account. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.